All right, so we are going to continue in 7.3. We did some 7.3 yesterday with logarithms. We introduced logs for the first time. Today we're going to graph logarithms. Okay, so for number one, we're going to graph a log that is fairly simple. We're going to go ahead and go with a base of 3. Oops, I said y equals. Okay, there we go. Y equals log base 3 of x. That's what I want to graph. For this section, I'm going to even ask or expect, certainly allow you to use a graphing calculator for this. So I'm going to make use of a graphing calculator. Hopefully I don't have too much glare here. Hopefully I can show you how to do this. So just like any time we've graphed, we use the y equals. So here we go. If you guys don't have graphing calculators, I would pause the video and get them out so you can practice this as well. But so once again, if that just happened and you're restarting the video, y equals is where we begin. We have to be careful about entering the log. You have a log button right down here next to your 7, but that's not the log we want. That log, it doesn't have a base number, so it actually only works for a base of 10. So there's a different place we're going to get the log, so I'm going to show you that. There's a math button right here, right below your green second. Hit the math button. You have to be in this screen first though. Hit the math button. It doesn't show up right away, but if you scroll down further, it's in this first menu, the math menu. But if you scroll down, we're looking for what's called log base. There it is. So it went through numbers 9 and then a 0 and then it switched over to letters. Letter A is where I find log base. So I'm going to select that. It's going to bring me back to this last screen, and now it's got a flashing cursor in the base spot where I can put any base I want, and I want a base of 3. So I'll put a 3 there. Now I'm done with the base. It's showing you a flashing arrow to the right. So you arrow to the right to get out of the base. Now I'm in the parentheses. What am I taking the log of? Well, just of x. So your x button, in case you don't remember, we want to use the button that's right next to the alpha button, the green alpha. There's an x, t, theta, and n, a variable button. Choose that button for your x. It's showing once again arrow to the right to get out of there. And that's it. That's the equation. I'm going to go ahead and hit graph. But the graph on here is a little bit flawed in that we can't see exactly what's happening here. But we can see a little bit about it. If I go to the table in blue, it's in blue right above graph, so I hit second, table, and get a little bit more clue. Notice it pops up. The first one says error. If I scroll up, I see a bunch of errors. What that means is that I can't plug in just every x. Some x's, when I plugged them in, it gave us an error. So there's a domain problem. So if you remember from graphing exponentials, we said the domain was all real. With logarithms, that actually changes. The range is all real. The domain is not. So where does the domain begin? Well, looks like we can't use anything through there, through 0, and then after 0 is okay. So I'm going to write down, there's a few things I'm going to ask you to do on this graph. We're going to graph, but we're also going to give the domain, the range, and we're going to give a table of a couple of values. We can take the values right off of this graphing calculator. So I'm going to ask domain, domain, range, and then I'll do a table of values. So the domain, it looks like x only works after 0, so we could say that x has to be greater than 0. The range, I just told you, you can't tell from this table Actually, you can see it's getting bigger, bigger, bigger. But what's the smallest value? You can't tell from this table right now because I can't see what's between 1 and 0. It's not showing the 1/2, the 1/4, the 1/8. And so I'm actually going to tell you every one of these logarithmic has all real numbers for the range. And we used this symbol the other day for all reals. You can use it again, or you can write all reals, but that's going to be your range. So table of values, just grab some of the ordered pairs that work nicely, like 1, 0 is a nice one. There's a lot of decimals, but here's one, 3, 1. You'd probably use that. Oh, I see another one down here at 9, 2. Now, sometimes I'll use 3, sometimes I'll probably only use 2 because these numbers might get just large too fast. These aren't so bad, so I'll probably go ahead and do 3. And then I'm going to actually add, so I said domain and range, but there's actually also a vertical asymptote. We had horizontal asymptotes before, but as we're going to see here with the log, there's actually a vertical asymptote. So I'll identify that in a moment. But let's plot those points. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 1, 0, 3, 1, 9, 2. So I can see as I'm traveling to the right, it is increasing, but it's getting less and less steep. And we saw that there was an error here at 0. Nothing to the left could be graphed. So right there at the 0 where the error began is where I have this vertical asymptote. Since it's a vertical asymptote, it's an x equals equation, and the problem was the 0, so x equals 0. So as I connect the dots, it's probably a little too steep there. As I get closer to that asymptote, you can't touch it and can't cross it, but you get closer and closer. And it's going to go down forever. And because it's going down forever, that's how I know the domain is all reals. It goes down forever, and this one goes up forever. It just takes a long time to get there. So that's what our graph looks like. So what am I expecting to see from you? Basically what I have listed here. The domain, the range, the vertical asymptote, table of values, and may contain just 2 instead of 3, and then a picture. But let's take one now, oops, with some additional numbers. Let's take 2, log base 2 of x plus 1 minus 3. So we're going to do the domain. We're going to do the range. We'll give the vertical asymptote. And we'll make a table of values. But let's plug that in the calculator. So I'm going to go back to my y equals. There's already that last equation. I'm just going to hit clear. Clear. In case you're not finding it, it's right below your arrows. It's over on the right corner, on the right side. Clear. And that wipes out the equation that was already there. And so now I can type in 2. And now I need log base 2, so I have to go back to log base. Remember, that's under math. So math is under your alpha. Math. Scroll down up to A. There it is, log base. Choose that. And now we can come back, fill it in. So log base 2. Arrow to the right. In the parentheses, I want x plus 1. And then I'm done in the parentheses, so you're going to arrow to the right again. That moves you out. And now you can hit minus 3. Make sure you do minus 3 and not negative 3. Right here. That should have been the subtraction sign, not the negative sign. If you mess that up, your graph will not match mine or the table. Okay? I'm going to go ahead and hit graph. And I can see right away my vertical asymptote must not be at 0 because it goes past 0. So it got shifted. It looks like it's over here further to the left. Well, this h value, the number in the parentheses, we call it the h, shifts it left and right, and it goes the opposite direction, just like it did with exponential. So this, we think of this as a negative one, so it shifted everything to the left one, so it shifted that asymptote 1 unit to the left also. So that means when I come to my vertical asymptote, I'm going to say x equals -1. And it's all because of that h value. That's the opposite of h, that's negative h. So I know in this problem that h is -1. Similarly, that's your k value. So your k is -3, but I don't really care about the k value in this problem. I did it with exponential, but with logarithmic I care about the h value. So that vertical asymptote is always x equals h, whatever your h is. In this case it was -1. And then that number shows up in our domain. Domain is always going to be x is greater than whatever your h value is, -1. So x is greater than h. So those are two rules that are nice to know, and your range will always be all real numbers. I'm going to go to the table, back on my calculator. Second table. I'm going to scroll up. Yeah, there's an error at -1. So 0, -3 was a nice nice number. 1, -1 is a nice one. Oh, there's another 3, 1. I'll go with those. That's sufficient. If you don't find 3 nice ones very close, then maybe you get away with 2. But I had 3, so I'd rather use 3 then. So at -1, we need to put that asymptote so we don't mistakenly touch it, cross it. The order pairs 0, -3, 1, -1, and 3, 1. Connect the dots, but don't cross the asymptote. I'd like to do one more. This will be our last one. Y equals, I'll give this a negative a value this time, so go with -3 log base 5 of x plus 2. Let's go x minus 2 plus 1. Now I will tell you, the larger the base number, the less likely you're going to, that may not be true. I was going to say, here we had a base number of 2, so it was easy to find a bunch of points. Here we had a base number 3, we got them, we had to stretch a little farther. Base number 5, we're probably going to have to go farther to get 3 points, so we may only be using 2 points this time. But let's identify the h and the k. The h in this problem, you look in the parentheses, it says -2, so we switch signs, so it's a +2. The k value is that last one, +1. I don't really care about the k value. Without even plugging this in the calculator, I can give the domain, the range, and the vertical asymptote based on the rules we talked about in the last problem. Domain, it's always x is greater than h. Here h is 2, so x is greater than 2. The range will always be all real numbers. The vertical asymptote is always going to be x equals the h value. H was 2, so x equals 2. Then I'll plug in the calculator to get some order pairs. So I'll go back to the y equals. I'm going to clear that equation. Now, this starts with a -3. So when it starts with that, you cannot use the subtraction. You must use the negative button on the bottom right here. So use the negative now, negative. And then if there's any other negatives in here, we use subtraction. Only the first thing should have a negative. -3. Now it's a log, so I got to go to that math. Scroll down to log base. That way you can select the base number. You need a base of 5. Arrow to the right to go into the parentheses. Looks like you need x minus 2 Once again, don't use the negative, use the actual subtraction key. And I mean the subtraction key on the right side, right below your multiplication, right above your addition. So minus your 2, arrow to the right to get out of the parentheses, and we have plus 1. We can graph just to look at it. Ultimately it's the table I care more about. Here it looks funky. It looks like it has an endpoint, but in reality, if I could draw it in, I would continue up, because it does continue. This graph looks not quite, or isn't quite right. That asymptote confuses the calculator a little bit. They can't. If I zoomed in, I'd probably see more and more of it. But understand the calculator's a little bit, the picture might be a little bit flawed, depending on your view. Let's go to the table, though, to get some numbers that are going to work nice. I see a lot of errors at the top. I would list the first one that's not, which is 3, 1. There's 7, negative 2. Now that might be all I graph. Let me go see how much farther I have to go before I get a nice integer. I have to go a ways. I don't want to go a ways, so I'm not even going to bother. I could, if I want a third point, I can pick any of these numbers that don't have an error. Just understand it's not an integer, but it'll give you an idea. But I think as long as we understand the asymptote and how this works, 2 is enough. But if you're not sure where that asymptote is, the more points you get, the better, so you understand the pattern and can draw the picture correctly. You don't see much pattern with only 2 numbers. But if you know your asymptote is x equals 2, that's helpful. 3, 4, 5, 6, 7. Okay, so 3, 1, and 7, negative 2, I guess. So what I see, just in those 2 points, as I go from left to right, it's going downhill, which means from right to left, it's going uphill. And I know I can't touch and cross the asymptote, so it's traveling up there. So the right side is starting to flatten out. The left side is following that asymptote. Don't cross it, don't touch it. So we get this picture. All right, that's the end of our notes for today.